In this video, I'm going to go through some examples of working with matrices, including multiplication, finding the inverse of a 2 by 2 matrix, and working with the matrix transpose. Let's suppose that I've got matrix A, which has minus 1, 2 in the first row and 4, 2 in the second row, and matrix B has 1, 4, minus 4 in the first row and 4, 4, 1 in the second row. So matrices A and B are different sizes. But can I calculate this matrix product AB? So to find out whether we can do that, we need to check whether the number of columns in matrix A, which is 2, matches the number of rows in matrix B, which is also 2. So they do match, and so I can calculate this matrix product. So how are we going to do that? So let's write down the matrices next to each other first, like this. And let's take the first row of matrix A and the first column of matrix B and calculate the inner product. So we'll have minus 1 plus 8, so we're going to have plus 7. Next, take the first row again, but this time take the second column of matrix B and calculate the inner product. So we'll have minus 4 plus 8, so we'll have plus 4. And then just keep going. So first row, third column, inner product is 4 plus 2, 6. And then second row, first column, inner product is 4 plus 8 is 12. And then second row, second column, inner product is 16 plus 8, 24. And then lastly, second row, third column, inner product is minus 16 plus 2, so minus 14. So there we go. How about BA? Could we do that? So B has 3 columns and A has 2 rows, so those two numbers don't match, so we can't calculate that. So this matrix product does not exist. How about calculating a matrix inverse of matrix A? What does that look like? So to do that, first thing is to calculate 1 divided by the determinant of matrix A, and the determinant of matrix A is these two numbers multiplied together, so minus 1 times 2, subtract these two numbers multiplied together, so minus 8, so minus 2 minus 8, so minus 10. So I'm going to put the minus up there, so we've got minus 1/10, and then we take matrix A and we swap these two numbers on this diagonal, and the numbers on this diagonal, we leave them where they are, but we negate them. So 2 becomes minus 2 and 4 becomes minus 4. So swap the two numbers on this diagonal, so 2 there and minus 1 there, and then negate the other two numbers, leaving them where they are. And then let's simplify that. So minus 1/10 times 2 will be minus 1/5. Minus 1/10 times minus 2 will be plus 1/5. Minus 1/10 times minus 4 will be 2/5. And finally, minus 1/10 times minus 1 will be 1/10. Anytime we calculate a matrix inverse, we should check that we've done it right, because it's really easy to make a mistake. And the way to check it is to write down the original matrix and just multiply it by the matrix inverse that we've just calculated. And if I've done it correctly, I ought to get the identity matrix for this matrix product. So let's see if we do. So first of all, first row, first column will have plus 1/5 plus 4/5, which comes to 1. Second entry up here is going to be first row, second column, so minus 1/5 plus 1/5, 0. And then second row, first column, so we'll have minus 4/5 plus 4/5, so 0. And then finally second row, second column, we'll have 4/5 plus 1/5, so 1. So we have done it correctly. Finally, let's work with the matrix transpose. So B transpose, what does that mean? It means we take matrix B and we interchange the rows and the columns. So instead of a matrix with 2 rows and 3 columns, B transpose will be a matrix with 3 rows and 2 columns. So let's write down what B transpose looks like. So it's going to be 3 rows and 2 columns, and the first row will be, the first row will be the same as the first column of matrix B, and the second row will be the second column, and the third row will be the third column. And then A transpose, same thing, it's interchange the rows and the columns, so the first row will be the first column of matrix A, and the second row will be the second column. Let's multiply these together. So I'm going to have first row times first row, first column inner product, so minus 1 plus 8, so plus 7. And then we'll have first row, second column inner product, so 4 plus 8, so 12. And then second row, first column, we'll have minus 4 plus 8, 4. And then we'll have second row, second column, so 16 plus 8, 24. And then third row, first column, so we'll have 4 plus 2, have 6. And then finally third row, second column, we'll have minus 16 plus 2, we'll have minus 14. And notice that what we've just calculated is the transpose of what we calculated earlier for AB. So we've just demonstrated a property of matrix transposes, that this is the same as the transpose of matrix AB.